I'm going to answer question number 2 from written homework 4.3 and 4.4. In problem number 2, you're going to sketch a graph of a function f given a bunch of information regarding its derivative. Letter A, they're just telling us here some points that we can plot before we even begin. So when we plug in x equals -1, we get y equals 4. When we plug in x equals 1, we get the corresponding y value is -2. And when we plug in x equals 3, the corresponding y value is 1. You just plot these points the way you would for any other function. And so that gives us 3 things that we know, or points that we can graph, that will help us sketch the graph when we're ready to do that. In letter B, what we're given is that f prime of -1, f prime of 1, and f prime of 3 all equal 0. This tells us that x equals -1, +1, and 3, that these are critical numbers. And this is important because remember, when you have critical numbers, those are candidates for local minimum and local maximum values. Typically, there's a hump in the graph when you draw the graph at these particular x values. Letter C is telling us that the first derivative is positive on certain intervals. And remember, if the first derivative is positive, the original function f must be increasing. And in this particular example, the intervals we're given is x less than -1. So that's the interval -infinity to -1. We're also given that the derivative is positive on the interval 1 to 3. So on these two intervals, the original function f is increasing. Now, letter D is telling us something similar, but this time the first derivative is negative, which means that the original function f must be decreasing on these given intervals. And so the first interval we're given is from -1 to +1, the first derivative is negative. And then from 3 to +infinity, the first derivative is negative. Again, that means the graph of the original function is decreasing. And for letter E and for letter F, this tells us concavity. When the second derivative is positive, the function has to be concave up. And this is the interval 0, 2. And when the second derivative is negative, that means the graph of the original function must be concave down. And so when x is less than 0, that gives me the interval -infinity to 0. And then when x is greater than 2, we go from 2 to +infinity. I like taking these inequalities and writing them as intervals. Notice I did that also up there for the first derivatives. Now we're in a position to try to graph this function. So, here we go. Okay, there's the new page. So now I need to draw some axes. Let's do this in black. Terrible. Let's use my tool here. Let me draw a line. There's 1. There's 2. There's 3. And there's 4. I'm not going to be particularly concerned about how accurate I am with all the labeling, but I know I have the point -1, 4, so I'm going to graph that. -1, 4, and I'm going to use purple. So say here's -1, and then let's go up 2, 4, 6, 8. So here's the point -1, 4. And then I have the point 1, -2. Go over 1, -2. And then I believe I also have the 0.31. So I'm going to go over 2, 4, 6, up 1, right about there. So here are the 3 points that are given. And now what I need to do is I need to use this information about the function increasing. So I know that the function is increasing from negative infinity to negative 1, and it's also concave down. So the function is increasing up to here. And then notice right when I get to negative 1, now the derivative is less than 0, and between negative 1 and 1, the function is decreasing, and it's still going to be concave down until I get to 0. So I'm going to come down here, I'm concave down, and then all of a sudden right here I become concave up. I start increasing again, going around the horn, and then back down. And you can look at this graph, and you can verify that it has all of the same properties, that, or it satisfies all the properties A through letter E. I hope this helps.